Okay, all right. Yeah, running back. Yeah, so this is our memory forensics workshop. My name is Jeffrey.
I'm Nick. I'm an intern.
I'm Salma, also an intern.
Hello, Luke. Okay, well, where did Luke go?
Luke said his mic isn't working, but he says he's Luke, so that's good.
Okay. All right. Well, yeah. So, um, yeah, this is our workshop on memory forensics. Um, so like a quick little interim slide here. If you want to follow along with our demos, which will be later in our presentation, we advise you download the memory dumps now, just so when we work with them later, they'll just have them available because the dumps are pretty large files. So yeah, so I guess we'll go into a little bit about like what is volatile memory and like what is even memory forensics. So volatile memory is basically the type of memory that is only retained when your computer's on. So the most common example would be RAM or your random access memory. Uh, and basically it stores information of like all your current processes and services that are running. And this is constantly changing because like the states of all your processes are changing and there's a lot of things happening behind the scenes on your computer. And so when we talk about memory forensics, what we're usually talking about is, for example, if we had a computer and we take a memory dump of it, we can examine it and we find out things. That is the forensics nature of memory forensics. And just to clarify a little bit, a memory dump is just a file with an image of the volatile memory, as in like the current state of what the RAM is. So to go a little more theoretical, let's clarify a little bit what processes are. So you might know like, for example, say you have like some exe file on your Windows laptop, but like it's not actually a process until you click it. Once you click it, it gets loaded into memory and it becomes a process. So like before that, it's just a program where it's just a bunch of code in binary. And then once you run it, it has its own memory in an address space, and it has its own processor state, as in the registers get changed with various loads, stores, adds, and whatever instructions. And there's also various other attributes and resources that processes have when they are running. So to go into them a little more, some terminology is that processes have threads. So a thread is sort of like just a function in the address space of the program. So this could be anything from just like some worker threads that are doing some like medial task labor of the program, or it could be some other like thing where all the threads are actively trying to do something and then they're actively trying to vie for some shared resource. But in any case, a thread is basically just a process that's like, it's like a sibling of another process where they share the same house, but they're not like separate entities to say. Another resource that a process has is its file descriptors. So this is just what a file has when it opens a file. Like for example, in Linux, when you call the open, it returns a file descriptor number, and then that just represents the open file. Similarly, there are socket descriptors, and we'll go more into socket descriptors and pipes right now. So for pipes, this is something that you learn a lot more about in CS111, but pipes are basically just used for inter-process communication. You might be familiar with in Bash, where you have the big vertical OR sort of symbol, and that you can pipe one's program's output to another program. And so this is an example of a pipe where it's just a one-way communication, but there's also other examples of pipes, for example, named pipes, which are duplex sometimes, or one way, depending on which one you choose. And you basically just write to them like you write to a file, for example, and then then the other process on the other end of the pipeline would be able to read it. Similarly, sockets are kind of like inter-process communication over network. So they're just like communication points for exchanging data over the network, like I said. So they have an IP address and a port, and they're bound to specific transport layer protocol, so either UDP or TCP. And going back to our Linux examples, sockets also sort of act similarly to file descriptors, where you just like call a write to the file descriptor and it sends it across the network. And a lot of APIs are like this, as if you look into the closer to the resource on the slide. Yeah, so going into some more Windows specific slides that will be relevant when we talk more, because most of our challenges involve Windows dumps. So handles are sort of just what Windows calls a resource. So you can think of it like a pointer to a process resource that you can't actually dereference. So while it hides the actual memory address from the API user, you can interact with it and then it can represent a lot of things like the ones listed here, like files, process identifiers, events, and desktops. And you'll see these all in volatility, actually, if you call the handles command. Another thing you might not recognize but see is dynamic link libraries. So basically, these are shared code between programs. So it saves space. Instead of having all the libraries in each separate program, it's just one sort of library of code, and it's loaded in during runtime. And like I mentioned before, this reduces memory, but this is also used by malicious actors for DLL injection. So for example, if you were doing internal hack for game hacking, that would also be like something you'd use DLL injection for. So this is where you just would be able to run arbitrary code in your process address space. And yeah, so now we are going to go into our demos, but we have the slide here just to link you. We also sent it in the announcement channel, but for the installation kit for the volatility, if you could download it, and we will be able to help you with any issues you might encounter.
Okay, so I am demo number 1, but before I start going into the demo and stuff, does everyone have volatility installed if they want to follow along, or does everyone just want to watch? Because there's not a whole lot of you, so yeah, just want to make the demo good experience, you know? So yeah, just let me know. Let me share my screen real quick though. There we are, very cool. Yeah, I can't see chat now, but okay. I am just gonna start if no one has any qualms with that. So volatility. Volatility is pretty good. It gets covered a bit in, oh, and I can't see the top of my screen because of this screen share thing, that's fun. So volatility is basically just something that's used to read these RAM dumps. Oh, oops, I forgot to add help. So first of all, before we start doing anything, we can take a look. There's a whole bunch of commands available with volatility. We're not going to use all of them right now. You can take a look into more of them later. But I'm just going to go through a couple of the more relevant commands that you're going to need if you start your challenges. So whenever we are using volatility, we have to make sure we have this prefix that just directs us to the volatility executable file. So this is where mine is. Let me make sure I spell it right. So we want to be analyzing my dump file. I called it test.elf. So we did the file, we put the file name, .elf, and then the first command we normally want to run would be image info, which I'm not going to run it because it takes a while. But image info, you're going to want to run it anytime you're presented with an unknown memory dump, because what it does is it finds possible profiles for which to interpret your file, like the operating system. It finds a whole bunch of other stuff as well, hence why it takes a decent chunk of time to run. But I already know what profile my memory dump is on because, I wrote it. So we're just going to use that. So before you want to do any further analysis, you do need this profile. If you try to run any commands, like most commands besides image info, it's just not going to work without a profile. So we put in our profile. My memory dump's on Windows 10. Wait, let me minimize these. There we go. My memory dump's on Windows 10, so we put that in. And the first actual command we're going to run is the ps list or process list command. So what ps list is going to do whenever it finishes running is it's going to print out this sort of table that lists all running processes. It's going to list their offset, the process name, process ID, there it goes, parent process ID, threads, handles, et cetera, start time, exit time, all of that jazz. So we have a whole bunch of processes running, as you can see. A lot of these are pretty typical. You're going to see a lot of these SVC host processes, all that jazz. So we scroll down, we take a couple looks. We can see, where are we? We've got Microsoft Edge running, which might be interesting. We can see this notepad.exe file is open as well with a process ID of 3364. Let's remember that for later. So we've got, more Microsoft Edge stuff, a couple of Internet Explorer things as well, which we're going to look into more detail at those later. But right now, let's just take note that they are there. Everyone caught up. I'm just going to keep going. Yeah, feel free to stop me at any time, by the way. So yeah, we've got notepad.exe running. We've got these Internet Explorer, Microsoft Edge. Those are right away the ones that jump out that might be relevant. Because we have Internet Explorer and Microsoft Edge and all that stuff running, we can use the netscan command to find the local address of the machine that our dump came from. So netscan, it finds a whole bunch of stuff, and it's pretty useful to check for any specific suspicious communications. So once this thing goes, see, well, yeah, we get the offsets, local address, foreign address, process ID, times created, state, so like, is it still active, still listening, what's going on there. See, we've got a whole bunch of them with process ID of -1, they're established, they're done. But yeah, we can see our local address over here. Yeah, netscan, very cool. Not insanely relevant at the moment, but it is good to know about and useful. So back to the processes we saw earlier, the Internet Explorer and the Microsoft Edge. We want to know which of these are actually relevant to us, but the ps list command alone doesn't really tell us a whole lot of detail about what's going on there. So we can run the command line command, which will display our process command line arguments. So it'll basically do something very similar to process list, except it'll also show, like the location. We can see right here, command line, all this stuff. So back to the top. So yeah, a whole bunch of things. Where is the thing that I'm looking for? Explore, where is it? The thing in particular. Oh yeah, by the way, here's our notepad.exe file with this process ID, and we can see the name of this text file is cyberdemo.txt. That seems like it would be really relevant right now. So yeah, we're going to really take note of this process ID for our next command. But in the meantime, we can see right here, iExplorer.exe Internet Explorer with this process ID. Oh, sorry, this one. So this is like our base Internet Explorer, regular command line. And then we have these two right here with process IDs of 2576 and 812. And they've got this extra bit attached to them, this scodef, crit@, et cetera, et cetera. This is just like, you don't need to worry too much about that. It's just indicating that a search was done here. So ordinarily, we'd want to look at both of these searches to see if they have anything relevant. But I already know which one is the relevant search. So we're just going to look at this one with process ID of 812. But if you were doing this yourself, I'd check out both of them. So the process IDs that are still relevant to us right now, there's a little chat button. Okay. So the process IDs that are still relevant to us right now are process ID 812 and 3364. So we want to look more into these processes because, we can see that they're there, we see that they exist, but we can't really read what was going on there. So let me get rid of this volatility stuff for now. Wait, no, I forgot. I have to do something else first. Okay, so we want to run the memdump command. So just create a memdump of these specific addresses, process IDs. So this is our first process ID of interest, the Internet Explorer one. And then we want the dump to go into our current directory, hence dump directory, little period right there. So we'd run that. I already ran that before I started this, but what it would do is it would just create the memdump. I'm only screen sharing this tab, so I can't show you what it looks like in your files, but it'll appear there. And then you do the same thing for the notepad one with the process ID of 3364, and they'd just be files with the name like 3364 or 812 with the extension .dmp. So now that we have these dump files, we can go and try to read them. So we can first try to just output the whole thing, but that's a bad idea. As we can see, no, you can't read any of this. It's illegible, it's a mess. It's gonna be the same thing with the other one. So we want to get a bit more specific. And since we're doing a challenge here, we might think that our notepad file and our Internet Explorer search might have some string with the word flag in it. So since I'm on Linux, I can run this strings command. I think the equivalent on Windows is like find str. I'm not entirely certain though. So we can run that. And this grep command acts as like our filter. So we filter for the word flag. Oh, oops, strings. And there we are, good exploration. And let me cut that off because we found the flag. We can do the same thing for our notepad.txt file, and we'll find the associated flag there being, oh, unfortunate. So that's all I have for you, and I guess I'll pass it off to Nick right now.
Sweet. All right. Thanks for the demo, Salma. So Salma kind of covered some of the like the basic functionality of volatility and just what you want to kind of look at right when you begin. And I'm going to jump into a little bit more of the sometimes more advanced functionality or just a little bit of the different stuff you can do as well. So let me start sharing my screen. I can't share my screen. Yo, Henry, could I have screen share permission real quick?
Wait, okay. I am not the owner. Josh is.
Gosh, can I have screen share real quick?
It's fine.
Sweet, thank you. Okay.
Yeah.
Cool. Okay, so let's see, what do I want to start with? So I'm going to start with actually that same thing that Salma ended with, which was that grep command. So I'm going to start off by just showing how it works in general. So if I'm on, let me go up a folder. If I'm at my desktop here, you can see I have the bmovie script, and it's a pretty long file. If I were to just print it normally, bmovie script, it's pretty long. If I were to look for like the word B, I'd be looking for a while if I wanted to find all the instances of the word B, because it's the bmovie script. So if I take this command, the cat command, which just prints out the bmovie script, in this case, whatever file you're pointing to. And I use that pipe operator, and then grep b will find these are just the lines in the bmovie script with b. That in itself probably doesn't sound that useful to you. It isn't, but as Salma showed earlier, if you combine it with a volatility output, you can pretty easily filter down your output to what you're looking for. So for me, I have a file here called demo2.elf. I'll let you know if you're following along. I did upload it as a zip file, so you're going to want to unzip that before you can use it with volatility. So I'm going to go into my volatility folder and run vol.py. And let's see, my file is that demo2.elf, which is up one folder. And in this case, the profile is, you can use image info to find it, but I'll just give it to you right now. It's win10x64 underscore bunch of numbers 17134. And I'm going to just copy that for future reference. Oh boy. Okay. So if we were to do, oh boy, what has my terminal done? Wow. PSH is horrible. Okay, there we go. So if I go ahead and just run PS list, as we saw earlier, it'll output a bunch of processes. And say I wanted to, well, once it outputs all the processes, we'll see there's a bunch of them. Not too many, not an unreasonable amount to look through, but say we were looking, like Salma was looking for Microsoft Edge before, we wanted to look for just the Chrome processes, because that's the browser I have open in this dump. We can pass it into grep Chrome, and we'll see that it'll just list the lines with Chrome, and that'll make it a little easier to filter it down to what we're looking for. So I'll give it a second, it'll do that. And as she hinted at earlier, the equivalent on Windows, if you're following along and you don't have the Windows subsystem for Linux, you can type find str and then /c : and whatever you're looking for in the parentheses, or yeah, in the quotations there. So that would do the same thing on Windows. I'm on a Mac, so it's not going to work. So yeah, that's grep. It uses that pipe operator that Jeff was talking about earlier. It's piping the output of your volatility script into the grep command, which helps you out in this case in the terminal. Next thing I'm going to do is kind of switch topics over to just some general volatility commands. So if you're looking at a challenge and you want to know what to do, there's a couple places you can look for just getting some general info on where to start out. Obviously, you'll want to figure out the image info of the image you're analyzing, and then maybe look at the process list. But if you have some specific challenge and you know what you want to do, there was the help command earlier, and there's also the -- info option, which you can pass to volatility. And this will give you a ton of information about volatility. So I'm going to go through the first couple categories in this list. First thing it shows you is all of the profiles that volatility has by default. So I think this covers all the challenges that we have uploaded. They're either going to be on Windows 10, mine are on Windows XP. I'm pretty sure they're just on those two, but if there's others, you can see there's a couple other operating systems available here. It's all Windows. If you want to upload your own profile, it's a little bit of more of a process, but I'll kind of touch on that in a little bit. And then we have the plugins here, which you can see there's a ton of plugins on top of the memory dump and process list that we've already covered. So say you wanted to look at those handles for processes, there's a handles command, and it'll print out a list of the open handles for each process, which is pretty useful, pretty cool. You can see that there's a bunch of plugins available. The ones that start with Linux are for analyzing Linux systems, and the ones that start with Mac are for analyzing Mac systems. So you're probably not going to use those, but you can actually see the Windows plugins do continue after that. So there's quite a few. Probably don't need to worry about scanner checks or address spaces. One thing you might notice about this list of plugins is that these aren't the most useful descriptions. They tell you what it does, but they don't tell you in depth how to use these plugins. So another thing that you can look at is on the internet, there's actually a command reference by Volatility. They have a wiki. And yeah, on the right side here, we see Windows Core has a command reference, Windows GUI, and Windows Malware, in addition to Linux and Mac OS. So this kind of categorizes the plugins by what they're generally doing. So if we wanted to look at that handles command, we see it right here. And this gives you a little more information about how to run the command. In this case, it's just running handles, and it'll give you some output. But then say you want to display handles for a particular process, you have the PID flag. So this whole website here will just give you more in-depth documentation if you're trying to figure out something specific to do with volatility. let's see, was there anything else I wanted to cover on that? Oh yeah, there's also the GUI page, which is useful to look at. One of the challenges will use one of these commands. I'm giving you a little hint. These are useful commands as well, having to do with Windows. And then there's also malware. I don't believe we did malware challenges, but those are some other commands that are relevant for Windows and malware detection. And of course, if you haven't found anything, if you're looking through this list and can't figure out what you're trying to do, you can just Google it. You can say, try to figure out how do I look at the text in a notepad file on volatility, and there will probably be some article somewhere to help you out. So that's of course an option. And of course you can ask us a question along the way. So the next thing I kind of want to look at is, on top of all these plugins that volatility has automatically built into the program, which is a good amount, you might also want to do some functionality that other people have actually built up for you using custom plugins. And so one plugin directory that we're looking at today is Superponable's volatility plugins directory. He's made, he or she, I don't actually know, he or they have made a bunch of plugins. And one we're going to take a look at today is the Chrome history plugin, but they also have a Firefox one, a couple with malware. But yeah, we have a couple challenges related to Chrome history. So it's useful to know how to use this plugin and how you can install custom plugins. So the process for that is you just want to go ahead and download their plugins. So on the GitHub page, you can just download the zip, open that up. As we can see, we've got a folder here with all the plugins, and that's actually about all you need for downloading stuff. I'm going to put that on my desktop, close out these windows. And for volatility to know where to look for these custom plugins, you just pass in a -- plugins option. So I open up my volatility Python script, and then I can do -- plugins equals and that folder. So currently I'm within the volatility master folder. So I'll go up one and then volatility plugins. Did I misspell that? Volatility plugins. That should work. My computer is telling me no. Well, let's see if that works. I'll just run the info command real quick. Did this include Chrome history? Yes, it did. All right, so we see now that when I've run this with the plugins directory specifying that volatility plugins master, the info command is giving us a couple of those custom plugins. We've got Chrome history, Chrome search terms, etc. So going back to using those plugins, we use them the same as any default plugin. So I'm going to type in my file name here, which is demo2.elf, and my profile. That is not my profile. All right, I will type it out manually. x64_17134. And then we can just type in Chrome history. And one thing to note is that in this case, the documentation is just this one README page. So it doesn't actually tell you much more than the plugin names, but fortunately it's pretty self-explanatory. You type in Chrome history and it runs the Chrome history plugin. So I'm gonna hit enter on that. I'm gonna make this screen a little bit bigger so that it actually fits onto one line. Takes a little bit to run because it's doing a pretty complicated process here all for you. It's finding Chrome, any open instance of Chrome within the memory dump, and then it is looking through it to find an SQL database, which is how Chrome is kind of storing your history, storing a lot of data about what you're doing in your browser. And then it has to decode that SQL database, get out the entries that are relevant for the history, and then print those out to you. So it's a little bit of a process, all running in a Python script, takes a little bit of time. This is just me stalling and telling you how it works. Soon enough, though, we should see the Chrome history that was open for this. Okay, so yeah, we'll see it prints in reverse chronological order. Seems this person was a little bit questioning their life at the moment. It starts from the bottom and goes up. So we can see last visit, it started at 809, made it eventually up to 810. We just see a bunch of Google searches as the history. That's all there was in this Chrome browser. The process keeps going. Eventually it'll find some weird entries if I keep it going, but you can just cancel it early with Control-C, of course. And there you go. You've got what you need from Chrome history. So yeah, that's how you would use a custom plugin. You just got to make sure to specify that plugins directory of some plugins you downloaded. You want to make sure to do this before you type in anything else, like right over here, so that Volatility knows these plugins exist before it tries to analyze a file. There's other plugins available. I don't think we're going to need any of them, but if you're interested in looking around, there's Volatility Foundation community page has a bunch of contributors here. Each of these is just their name, so you kind of have to like click on it and go actually look at the individual plugins. But yeah, you can look around at some other plugins and download them if you'd like. Just make sure to put them in a plugins folder and specify it, and Volatility can use them. So I hope that was pretty helpful on how to use custom plugins. I think that's most of our presentation tonight. I'm going to stop sharing now, but feel free to ask any questions if you have any. And yeah, we have some challenges up on the Cyber webpage.